Good afternoon, ladies and gentlemen. Post-lunch session. Hello, everyone. It's great to see a full crowd. Today, we're here to listen to Sanket Amin, Senior Manager for Data Science at Collins Aerospace, talk to us about how Collins Aerospace is leveraging the Lakehouse and Apache Spark to keep aircrafts in the air. So, without further ado, thank you. Welcome.
All right. Full house. Thanks for waiting in the serpentine line outside, and thanks for attending this, even though there's not too many other things to do today. It's good to have all of you here. So again, my name is Sanket Amin. I'm with Collins Aerospace. I lead a data science and analytics team there, and what I'm going to be talking to you about today is our Essentia platform and how we leverage Databricks capabilities to deliver. So how many of you know what the picture on the right is of? Keys. I heard it. Key West. That's Route 1 leading down to Key West. It's been a bucket list dream trip of mine to take a convertible and drive it down this iconic stretch of highway from Miami to Key West. So for my 40th birthday, that's what I planned to do with my wife. Unfortunately, the plans did not go how I liked. On the morning of the flight, I received a text notification that my flight was delayed by an hour. Not too worried about it. I went back to bed and caught a couple more minutes of sleep. Later, I woke up to find yet another notification on my phone that the flight was further delayed. I called the airlines at this point to see and understand the reason, if I should make alternative plans or potentially cancel the trip altogether. Unfortunately, the airline didn't have much information. The agent told me, that the cause of the delay would be mitigated and that the flight would occur per the new time. So my wife and I gathered our things, headed toward the airport, still excited about our trip. We'd arrive a little bit later in Miami, but we could still make a good trip out of most of the day. While on the way to the airport, the flight was again further delayed. Now the flight was scheduled to depart in the early afternoon. I now became nervous of either more delays or a full cancellation. But my wife assured me everything was going to be okay, and we checked in at the airport, went through security, and decided to grab lunch. But sure enough, the flight would be delayed another few times. At this point, we would end up reaching Miami in the evening and drive to Key West in the dark. What was the point? The trip was no longer worth it, and with frustration, we ultimately decided we're going to cancel our flights and go back home. From home later that day, I found out that the flight eventually did take off approximately 12 hours after the original departure time. So why was my flight delayed that many times? In this particular case, it was due to an aircraft maintenance issue. How many of you have experienced this? Perhaps some of you experienced this on your way here to the conference. Does it feel like delays and cancellations are occurring more frequently? If you thought they were, you wouldn't be totally wrong. The government compiles the list that you see on the left of the reasons delays and cancellations occur. And it used to be that the national aviation system was a large driver of these interruptions for the majority of the time. But in recent years, especially since the pandemic, we've seen a significant uptick due to the airline operators themselves. Now, a lot of us as passengers might really think, are the airlines really even focused on solving this problem? But in reality, delays and cancellations cost the airline big dollars. A major US airline could potentially see an upwards of $8 million a month lost. Additionally, emerging regulations in the European Union and in the US, the airlines could impose heavy regulations per passenger, fines per delay and cancellation. So it's a big problem for them. At Collins Aerospace, we're looking at solutions to help airlines deal with the problems of delays and cancellations. And while we work on a variety of solutions to help the airlines in this way, I'm here to tell you about one particular product today, Essentia, that helps avoid unscheduled maintenance events. And of course, I'll discuss how we leverage the Databricks platform and capabilities to deliver that. First, I got to pay my way here, so I'm going to talk about Collins Aerospace. Collins Aerospace is one of 3 companies under RTX. The other 2 are Pratt & Whitney and Raytheon. So Pratt & Whitney makes a lot of jet engines, probably a jet engine that you've flown on in a commercial aircraft. They also make military engines as well. Our Raytheon business is focused on a heavy military portfolio with products ranging from space systems, cybersecurity, weapons, and missile systems. At Collins Aerospace, we pretty much focus on everything else. My favorite thing to mention is the diverse set of products and services that go into a commercial aircraft. It could be the seat or the actuators that move the aero surfaces or the landing system or the wheels and brakes. We even manufacture the cabin air management systems, much of the cockpit controls and avionics, and even the laboratories. So next time you're sitting in a commercial plane, look left, look right, look up, look down. You're probably looking at a Collins Aerospace produced component. We have a large, rich history in the aerospace industry, and so our next evolution is particularly exciting. We recently created a new strategic business unit within the company named Connected Aviation Solutions, or CAS, and we are leading the digital transformation in aerospace. We not only make things that go into the plane, but now we're also serious about the data that moves around in the aerospace ecosystem. Leveraging those heritage data networks, we launched Connected Aviation Solutions in 2021 to deliver new products, service, and solutions with data at the center of providing the value. We have customers ranging from airlines, airports, business jet operators, business jet manufacturers, and with our recent incorporation of FlightAware, regular web and app users like you and me. Our motto at CAS is, as aviation connects the world, we connect aviation. And we're doing that by offering a full end-to-end digital product portfolio. Our products range from the hardware and software and devices that collect data from the plane to the transmission of that data and information to satellite systems or ground-based systems, the movement of data on the ground, to services at the airport such as baggage handling, check-in kiosks, gate management systems, and even business aviation support services. Okay, enough company branding. We're going to get back to the story of Essentia and Databricks. So what is Essentia? It's our product offering towards predictive health monitoring, typically abbreviated PHM in the industry, again, to help airlines avoid delays and cancellations due specifically to maintenance issues. Essentially, it's about becoming proactive rather than reactive with aircraft maintenance, forward-looking versus rear view looking. A large portion of my career has been in developing PHM particular solutions, so the concept is not new, but it has yet to gain significant traction due to the complexity of developing, testing, and deploying predictive analytics. With Essentia, we offer a comprehensive suite of capabilities to monitor, review, and take actions on either curated, hand-picked maintenance recommendations by our fleet monitoring service team, or leveraging self-service capabilities that are built into the web-based platform. While there are many similar offerings in the PHM market, we believe we have a unique advantage at Collins Aerospace that enables us to be a leading solution. Many of the solutions are limited to a particular airline or aircraft or components and systems of the plane. Our platform is airline and aircraft platform agnostic, meaning we can be a solution for every airline, a Boeing or an Airbus, or even small business aviation. But more importantly, a key differentiator is that we make many of the parts and components that go into the aircraft like you saw before. And so who best to develop those predictive analytics rather than those that actually make them? Many of our analytics that we've deployed is the combination of combining a design engineering expert for the component with a data scientist. So I'll spend the next few slides summarizing our journey in developing the Essentia platform. In the early days of development, it really felt like we were trying to fly as fast as we could by flapping our arms and running real fast. We knew what we wanted to do, but we were a traditional aerospace engineering company, and we were starting from square one. A data science team was assembled in our central engineering organization to investigate whether we could develop predictive analytics for Essentia. The first members of this team were limited to performing analysis on their standard company-issued laptops with MATLAB. The laptop is where all our data architecture, from ingestion to ETL to data science analysis and finally visualizations via PowerPoint, lived. Trying to analyze 2 months worth of data for a handful of aircraft was somewhat doable, but not scalable. We quickly realized we needed a cloud environment for the ability to store, process, and consume large volumes of data. We eventually did migrate to a cloud environment where we started practicing with native data science and machine learning services at first, but they were proven to be cumbersome and complicated to use. We ultimately needed a solution that was going to make it easy to prototype analytics and test it against a large data set. So what does big data related to flying exactly look like? It satisfies many of the V's of big data. For volume, we've collected already terabytes of data from aircraft to maintenance systems. Velocity, we see data coming in on approximately 50 gigabytes each day. Variety, we gather all types of data, including sensor data, weather information, aircraft position tracking, fault codes, and maintenance logs. Value, I talked about the value of it for predicting faults, but we can also extract value for what-if analysis and operational monitoring. Veracity, the veracity or trust in the data varies depending on the data type. For example, if we have high veracity in our sensor data because it's directly from the source, but the maintenance information data is somewhat lower because sometimes that information is handwritten or typed into a computer by a human. So our Wright brothers moment came around in 2019. And this is when I joined, but that's not the reason why. Rather, the team of data scientists I joined were comfortable working in the cloud due to Databricks and churning out analytics. Our organization was the first within Collins Aerospace to leverage the Databricks platform. So we had to learn on our own, but the ability to code in Python and leverage the notebooks made it easy to adopt and train others. PySpark allowed us to leverage the parallel processing capabilities of Spark, but avoid the need to know how to program in Scala. And we connected our data ingestion process to load aircraft data into Delta tables, enabling greater efficiency in our batch processing efforts. We reaped the rewards of this in particular with one tool called Answer. Answer is a homegrown tool that we developed to help scout for potential analytics. A lot of times an engineer, we couple a data scientist with an engineer and they'll have the known knowledge of saying how this component works and give us a good idea of what analytic to go develop. In some cases, we exhaust all those ideas and still don't have a good analytic to go deploy. So Answer is utilized to help us look at all the different signatures available from the plane and see if we've missed anything. The goal here really is to leverage the massive aircraft data set that we have and examine it for basically abnormal signal variations related to an event of interest, like an unscheduled maintenance. For a single flight, we are producing approximately 168 statistical features that we evaluate for correlation. Now it's correlation, not causation. So we still take it back to the engineer and review it with them and say, does this make sense? Because of this massive data sets, we would see costs and times as indicated on the slide when we would process certain larger data sets. Through partnering with Databricks and Insight, a partner consulting company, we implemented improvements to process and hopefully achieve reduced costs and time. Some of these improvements included orchestration and automating the processing using a combination of notebook widgets and Azure Data Factory. We also looked at how we were calling Spark and made some refinements to that. But a majority of our improvements came with a few lines of code to optimize and partition the way we structured our feature data in Delta. After implementing those improvements, we achieved a nearly 80% reduction in cost while speeding up the processing on the same data set. This made it much more affordable for us to process customer data through this important tool, as well as set it up for periodic reprocessing on new ingested data sets. Now that we could create analytics, the next objective was to rapidly deliver to production. Everyone loves a good reference architecture diagram. This is a close approximation of how things are set up today. We're leveraging the Delta Lake for our primary steps of ETL and transforming the data from raw, refined to curated, i.e. bronze, silver, and gold. Depending on the data source, we have orchestration of data ingestion through Azure Data Factory or Databricks. The really neat capability about this setup is the ability for our data science to own their CI/CD with their predictive analytics. Originally, we depended on a software engineering team to help us deploy analytics so that they could feed the Essentia front-end website. With our current architecture, data science is in complete control and responsibility. Data scientists can now reach into their refined and curated data tables, develop their analytics, but also they have set up the jobs, the batch processing, to periodically process the analytics through new nightly incoming data feeds. As you see, Databricks is leveraged all across the architecture, from ingestion to data processing to data serving, but it also still gives us the flexibility where we need it to use specific services like SQL Database and Cosmos. So we went from having zero analytics, a handful of data sets, to deploy to today an application that is servicing hundreds of aircraft with over 50 analytics. All this within a span of approximately 5 years, and all this resulting some of our customers a potential 30% decrease in potential delays and 20% decrease in unscheduled maintenance. So where are we headed next? One of the goals this year is to achieve multi-cloud interoperability. As a fairly large organization, we have lots of data sets distributed among many cloud environments. We're mostly a mix of AWS and Azure. We have set up Databricks in both environments, and we are in progress of setting up Delta sharing to allow a connection between the clouds. This will increase the opportunity for data to be utilized and explored by data scientists and citizen analysts. As we expand our footprint, proper data governance is key. We focused on building data governance within the organization from the ground up. Within our data management and data science department, we have a specific team set up for governance. The 4 areas of governance they maintain are data management, data privacy, data rights, and data quality. These days, top data platform architectures are including data governance as a central key component. Again, with us being such a large company, we have many employees across the globe and data sets from many customers and government organizations with strict regulations. The ability to properly catalog, access control, and secure data is no longer just a nice-to-have option for us. That's why we're also leveraging Unity Catalog to help enable proper data governance. Another focus area this year for us is MLOps. Now, while there are various definitions of MLOps levels out there, our plan is to go from level 0, which is everything is manual, from training to testing to deployment to monitoring and updating. We hope to achieve level 1, which is our goal to at least automate the training, testing, and deployment part of the process. Eventually, ideally, we'll reach level 2, which automates the monitoring and updating stages of the process. We have started leveraging capabilities within the MLflow library within Databricks to assist us on this journey, specifically model versioning and the model registry. We also have developed code templates that facilitates easier transition of ML models developed by data scientists to production deployment. This eliminates the need for our ML engineers to have to recode a model that's been developed by a data scientist. Lastly, we're exploiting the partner universe that Databricks offers with other tools that we regularly use, leveraging capabilities like Databricks SQL connector and serverless SQL clusters to enable dashboards in Power BI and Tableau to allow engineers to analyze sensor data using engineering-loved tools like MATLAB. And one of my favorite current projects is developing custom data-rich data apps using Plotly's Dash Enterprise. Some of you may know about the Plotly visualization library, but Plotly Dash and Dash Enterprise extend this. We can now develop highly custom data-rich apps with the ability to embed those in websites like Essentia. It gives us the additional flexibility for our complex data sets where sometimes we are limited with other tools. And it also allows data scientists to develop unique visualizations, and when we find those are particularly useful, it's an easier transition to integrate them into production. Ultimately, we'd all like to see the departures board on the left, right? Our goal at Collins Aerospace Connected Aviation Solutions is to make that happen. And Essentia is just one of the solutions we're working on to achieve that. Transforming data into value is our mission, and we believe that will lead to a more sustainable, more efficient, more reliable, and enjoyable aerospace experience for everyone. And for those of you that are still wondering, I did eventually still make the trip to Key West. It was a terrific experience, and I highly recommend it to all of you. Enjoy the rest of your time at the conference.